Okay, so I just wanted to go over for my students this simple factoring idea because I know when we learn to factor that there's just so much going on and we forget some things. So this skill is just so important for the future in math in your future math classes. So in the past, plus bx plus c, right? We have our standard quadratic form. And for this, when a is equal to 1, many students are super comfortable. And we set up our parentheses and we have an x here and an x here because this is 1, right? So the formula is more like x squared plus bx plus c. And we find two numbers that multiply to c and add to b. And we fill in. But the minute we see something where this a value is not equal to 1, what do we do? And how do we solve that? So that's what the purpose of this is for my students. So let's see here. So the first thing to do always, right, is to collect all the terms, not always, but in this case, to one side. And then we start to deal with this. And what I suggest, because also when you learn a factor, you learn a bunch of other things like the discriminant. And what do we do with the discriminant? And so this is just such a useful little packet of information. And I'll show you what happens. So if we take our b value, which in this case is hidden, right? Negative x, there's a -1 there. So we take our -1 and we square it and we subtract 4 times a times c. That's going to be 4 times, I'll just do it all out, 2 times a -3, right? -3 is our c value. So what do we get? We get 1 squared. Any negative number squared is positive. Plus, right, we have a negative times a negative. What do we have? 4 times 2 is 8 times 3 is 24. So we don't really care about the whole value. What we use the discriminant for is for sign. If it's negative, positive, or we also care if it's 0, right? So we got a positive when we applied the discriminant, when we applied this tool to this quadratic equation. And when you get positive, what that means is that you definitely have two real solutions. So now you know you're not just in the dark, right? You know that you're going to get something. And so I think that's a really beautiful part of math is like what we can see and what we can't and what we're looking for. And you're kind of navigating through this forest, and then things start to become apparent and you find a solution. Okay, so now that we've gone over discriminant, we know that we're looking for two real solutions, which is awesome. We can go ahead and factor this with a little bit more confidence, right? There's something at the end of the road. So it's the same thing as when a is equal to 1. Now a is equal to 2. So we're just looking for two numbers that multiply to a times c now, right? So this is our a and this is our c. So a times c is equal to -6, right? A is 2 times a -3. So we're looking for two numbers that multiply to -6 and add to our b value. We're basically breaking up b. We're basically breaking up -1 into two b's that still equal our original b. So -6 breaks into, so our original factors were 3 and 2. So let's just see that. So see if that works, right? So -3 times 2, we already established is equal to -6. And -3 plus 2 is equal to -1. So we just found two numbers that when multiplied together equal a times c, and when added together equal b. And that's exactly what we were looking for. So now we can rewrite the equation. And let's see, maybe in this color. So now we rewrite the equation, 2x squared minus 3x plus 2x minus 3 equals 0. Now I think that we can all agree that all we have done is rewritten this equation, the original equation, here. These both mean the exact same thing. -3x plus 2x equals -x. So now what we have to do is factor by grouping. So what does that mean exactly? What that means is like we have 4 terms, right? 1, 2, 3, 4. So we need to collect them into 2 groups of 2 that will hopefully factor out. So what I do is I look for similarity. So is there much similarity between 2x and -3? There's an x, but it seems like it makes much more sense to group 2x with 2x squared, right? So let's try that and see what we get when we do that. So we're going to go 2x squared plus 2x minus 3x minus 3 equals 0. So now we can start to see the light at the end of the tunnel a little bit here. So what is a way of factoring this? So we could pull out, I think about it like a vacuum cleaner. What can we pull out that's the same? We can pull out 2's and we can pull out an x. And so then we have x plus 1, which is very nice. And then what can we do here? We can pull out a -3. And now we have something that's the same. And this becomes x plus 1. And that's like a magical moment when you start to when you see how something can distill into something much more simple to deal with, because now we have the very important zero product property that we can use to solve this, which says that a times b is if a and b are equal to 0, then either a is equal to 0 or b is equal to 0 or both. That's the only way for this to hold up, and this is true. So one of these has to equal 0 or both. So we set 2x minus 3 equal to 0, and we get x equals 3/2, or x minus 1 is equal to 0, right? And if x minus 1 is equal to 0, then x is equal to 1. Or sorry, x plus 1 is equal to 0, then x is equal to -1. So then our final solution is x is equal to 3/2 -1. And that is the answer. So that's an example of factoring with AB not equal, with the A value not equal to 1, but also using the B squared minus 4AC, the discriminant, to help realize that now in the end, yes, we do have 2 real solutions, right?